Welcome, everyone, and thank you for joining us today. My name is Paul Donahue, and I will be your host. We ask that you please keep your device muted during the session, and if you have questions, please direct them to me via the chat function. We'll do our best to answer the questions at the end and to follow up with any unanswered questions by email. As I think you know, these Tech Talks have been designed to provide straightforward insights into radio frequency components. We talk about the related technologies, different applications, and certainly the extra design and manufacturing and engineering value that is added by a custom manufacturer such as Quantic TRM. To begin today's session, I am once again pleased to introduce Quantic TRM's Chief Technology Officer, Shaun Moore. The author of 2 U.S. patents and numerous white papers and technical articles on passive microwave technologies, Shaun has been with Quantic TRM since the late 90s, and his passion for the job and for solving problems has only increased over the years, especially when it comes to resolving customers' design and engineering challenges. So welcome, Shaun. Can you share an overview of today's topic and your objectives for the session?
Yeah, certainly. Thank you, Paul. So today we're going to talk about directional couplers. And we're going to start off by saying really what is a directional coupler. We'll then go through several applications for how you would use a directional coupler and really why you would want to use a directional coupler. We'll have a summary, and then we'll wrap it up with some Quantic TRM differentiators.
Okay, so to get started then, what is the best definition of a directional coupler?
Okay, so directional couplers are a very interesting sort of component. They are 3-port devices. There is what we refer to as a through line. So this is a low loss transmission line that runs from one end of the part to the other. And going through the through line, there is very little change of the signal going through the through line. There's a little bit of insertion loss and coupling loss, but the signal goes through largely unchanged. Then there's the coupled port, or the third port of the device. What this port does here is it samples a bit of the signal that's going through the through line and brings that out to the coupled port. This does it at a controlled level. Levels vary from say 6 dB to 50 dB or more. The coupling can be customized to virtually any power level that you require. The coupled path only sees energy going from the input to the output. It does not see any of the signal going from the output to the input. Therefore, that's why we call it a directional coupler, because it only samples energy flowing on that through line, moving in one direction. In the other direction, it's referred to as being isolated. There are certain performance parameters that we refer to how good that isolation is. The term you very often hear is directivity. Directivity is the reverse isolation minus the forward coupling value, and that difference is referred to as the directivity, or the quality of the coupler, or how good it is in identifying the direction of the energy going just in the forward direction as opposed to the reverse direction. If you start thinking about other sorts of devices that could possibly be referred to that could sample some energy, a resistive network, for example, can sample energy. However, it is not directional. It would sample the same energy flowing in both directions. Because of this directional nature of the coupler, there are some very unique applications that you can use to use this device, and we'll be talking about that next.
Okay, got it. And maybe could you give us an example of how a coupler might be used?
Sure. So like I said, I did talk a little bit about this already, but then the beauty of a directional coupler here is that you can sample a signal without really changing the signal that's going through the main line. And basically, signals come into the input. The main signal goes right straight through the component out the output, and then some of that signal or a sampling of that signal comes out the coupled port. The part that's on the screen right now is the DCS 1085. The Quantic TRM DCS 1085 is a 10 dB coupler. Therefore, the signal that appears at the coupled port would be 10 dB down from the energy going down the main line of that coupler. And like I said, it is an exact copy of what goes through there. This actually is very useful for a lot of applications where you need to have a sample of a signal going down the line. For example, if you have a transmitter or some other device and you need to lock, phase lock something together, they can use this to do that. We'll get into some more applications in a little bit, but there's a lot of very good things in circuits where you actually need to have we need to split energy, but you don't necessarily need to split it evenly from a power standpoint, and therefore directional couplers work very well in doing that. They're also reciprocal devices, which means that you can use them for inserting energy onto a line. And we'll get to that in a few minutes.
Okay, and how about in high power environments? What would you say about that?
Sure, we can build the same circuit just to be able to handle more power. These sorts of things are very useful when we get into right on the output of high power amplifiers. And in this case over here, if the control level for how much power that the amp is putting out, you need to determine how that is. So make sure you get a nice constant power output, or make sure that you don't, when the power stays at the level really where you want it to be. You can use this as a sampler directly on the output, and therefore you can make adjustments to your amplifier to go through there and make sure that you're putting out the correct power at all times. So basically now, because we're looking at the energy only looking on the forward direction, you can go in there and you can see exactly how much power you're putting out at any one given time without really attenuating any of the power. These devices have very good return loss on all 4 ports, and therefore you can actually sample the power in a nice clean way to determine exactly how much power you're putting forward.
I have also heard you speak about dual direction couplers. Can you explain?
Sure. Now, a dual directional coupler is essentially just 2 directional couplers in a single package. So what happens here now is once you do this, you have one coupler or one port that will sample the power going in the forward direction from the input to the output. The other coupler is essentially turned around so that now it will sample the energy going from the output back to the input. And those 2 couple ports are now isolated from each other. Therefore, you can actually look at the forward and reverse power simultaneously. The definition, for example, of VSWR, which is a parameter that we're all very much concerned about, this dual directional couple allows you to measure the VSWR directly, because you can now go in there and you can measure the forward energy and simultaneously on the exact same line measure how much energy is being reflected back on that same line in the reverse direction. So since the VSWR is a ratio of the reflected energy divided by the forward energy, you can then go ahead and do make that measurement and look at the VSWR of your part at high power in real time to determine exactly what VSWR you're getting on the system. This can be used in numerous applications, especially if you're looking at trying to find a fault in your antenna system or something else on the line. You start seeing a high VSWR reflected back. You can then take measures to make sure that you don't damage your amplifier due to high VSWR.
Well, are there other applications beyond VSWR monitoring?
Absolutely. So another big element here that we can use the directional coupler for is for using the directional coupler backwards. So instead of actually having the main signal that you're looking at going down the through line, you can actually take whatever signal that you want to inject onto a line by simply having that signal go into the coupled port. If you put energy into the coupled port, it will then reverse couple because it's a symmetrical device, and that energy will appear back on the through line. This has numerous applications for if you need to either combine signals where you need to have an asymmetrical sort of combining effect. But the other thing also really where this is really important is if you want to have inject a known signal onto a line to start making corrections, whether it be a phase correction or an amplitude correction, or try to balance off other sorts of lines, you can put these multiple devices on multiple lines to go through and start doing some software corrections for amplitude and phase errors that can happen going over long transmission lines from apertures and from antennas going back down towards the avionics. So there is a plethora of applications that involve actually using a directional coupler in its reverse direction by injecting a signal into the coupled port, which can put a known signal onto a low loss through line for other parts of the system. Like I said, from putting a reference signal onto a line or many other applications, this is a very useful way to use a directional coupler.
Well, excellent information as usual, Shaun. Can you summarize?
Certainly. So directional couplers are sort of a unique device in the fact that they are sensitive as to the direction of the energy that's flowing on the line. Energy that's flowing from the input to the output a small sample of that will appear on the coupled port, whereas energy flowing from the output back to the input will not appear on the coupled port. So in that case, they are directional, hence the name, and because of that unique ability to be able to split off energy and be sensitive to the direction, there are many things that you can do with it. You can use it for sampling signals on transmission lines, both at low power and high power. You can put two of these devices back to back, and therefore you can look at VSWR monitoring in real time, or you can use the directional coupler in the reverse direction by injecting energy into the coupled port and having it add energy and inject it onto the through line path, having that energy appear at the input port of the directional coupler, allowing you to put a reference signal onto an otherwise solid transmission line.
Terrific. And can you maybe just tell us a little bit about what's different about the way Quantic TRM interacts with customers?
Sure. So basically, Quantic TRM, we like to work with our customers. We like our customers, and really we like to go through there and make sure that the device that you receive is the exact device that you need. So we are looking at going in there and making sure that we select the design approach, the design materials, and we package things in a way that is consistent with how you need your components. We also do in-house testing to make sure that you have the objective evidence that your program needs to be successful. And as kind of a sum-up statement here is we want to make sure that we're a solution provider for you and your customer, making sure that the solution that we supply you is indeed the solution that you need, and you don't need to do any additional work after you receive the components.
So in other words, going beyond just being a source of the components.
Exactly.
Okay. Well, I think we have time for at least one question. And the one that I received here says that I see that there are different types of couplers listed on your website. Can you give us a quick overview of what makes them different?
Sure. Now that's actually a very good question. I did not discuss that here today. Today was more about the general application of directional couplers. There are many ways to build a directional coupler, and based on the construction technique, we have Quantic TRM has these different series of directional couplers on our website and in our catalog. At very low frequencies, these directional couplers are built using wire wound lumped element technology, where it is a series of mutually coupled inductors that do provide the same directionality as described here. And then as power increases, for example, then the size of the transformer would simply get larger. That technology is good for very low frequencies. Once you start getting a little bit higher in frequencies, We then move over into coupled line technology. Coupled line technology works really well at higher frequencies for two reasons. First, the package size becomes more manageable because the length of the coupled line structure we need to be able to build these gets smaller as the frequency gets higher. And once you get up into say UHF and L band, then the lines get short enough where they're manufacturable. In that technology, again, there is, because of energy flowing down the line and the electromagnetic fields that are generated, again, there is a direction to those fields, which then creates the directional coupler effect. So there are a wide variety of ways that you can build a directional coupler. The various components that we have up on our site really address all of those different sort of technologies. And as kind of a summary here, Quantic TRM builds in virtually every manufacturing technology available for microwave components, with the exception of waveguide.
Terrific. Well, I think that in conclusion, the bullets on your screen here really say it all. If you are a customer or somebody who might like to become a customer and you have more questions, we would love to hear from you. Please call our engineering hotline. The number is on your screen, 888-677-6877. There are no costs associated with these conversations. If you're one of our field sales reps, then you know that your calls are always welcome too. And looking forward, or going forward, our next Tech Talk will be on Tuesday, June 25th, and the topic will be Beamformers 2.0. Thanks again to everyone, and thank you, Shaun.
Thank you, Paul.